Alright, this is lesson 93, graphic parabolas. We've done this before in Algebra 1, and we even did this earlier this year, but we haven't looked at it in the context of this unit called conic sections. And so what we're going to do today is going to be very familiar, but we're going to look at it with the H and the K, and we're going to look at some other details and graph it. But it should be pretty easy and straightforward. Once we do it a couple times, you'll be like, oh, I remember doing this, okay? So we just use the different form. We use the quadratic form of these equations. But just a little review. The parabola looks like a quadratic equation. Opens either up or it could open down. Okay? So just a quick review on that. Put my notes here. Here are the steps for today. Ensure that the equation is in standard form. This is our standard form for a major Y parabola. In the next few days, I'm also going to teach you how to do the major X, which opens sideways. Here we identify H and K. Identify A. H and K, by the way, represents the vertex. A is really important because A tells us if it opens up or if it opens down. And then we're going to pick values to left to right of the vertex to solve for Y and then plot the graph. Okay, so watch me do a couple of examples here. Good? Yeah. Okay. Cool. So here's number one. Y is equal to the sum of x minus 3 squared minus 6. Okay. So the first thing I want to do is figure out where my vertex is. So we know this is H and K, just like normal. H is always next to X, so it's X minus H. So in this case, H is 3, and K is negative 6. So we're going to write down 3, negative 6, right? Because it's supposed to be H, X minus H. So since it says X minus 3, we know 3 is positive. So that's my vertex, and I could actually plot that point, 3, negative 6, on my graph. The next thing I want to do is look for A. A is the number in front of the parenthesis. There is no number there, so we assume there's a coefficient of what? 1 there, right? So since A is 1, we know that it's going to open up because it's positive. If A was negative, then we know it opened down. But in this case, it opens up. So I could even draw a picture up here and just know in my head that it's going to open up like that, right? That's not what it's going to look like, but that's what it's going to, we could predict it's going to open up. Okay, since we know that, then we're going to make an XY table. The nice thing about quadratic equations is that they are symmetrical, meaning that they're like your face. If we were to draw a line down your face, you should have a symmetrical face, eyeball on this side. Therefore, we could assume there's an eyeball on this side, right? Ear on this side, where should there be another ear? The exact opposite side, right? Because it's symmetrical. Same thing with our graphs. The vertex is the exact center, so we know that points on one side will reflect exactly on the opposite side. So we're putting the vertex in the middle here of our XY table. So I pick a couple smaller points than 3. 2 smaller points than 3 are 2 and 1. 2 bigger points are 4 and 5. Now I'm going to start putting in numbers. So 1. 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus 6 is negative 2. Okay? Now I'm going to put 2 in. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 6 is negative 5. Okay? 4. 4 minus 3 is 1. 1 squared is 1. 1 minus 6 is negative 5 again. Last one. 5. 5 minus 3 is negative 2. I'm sorry, 5 minus 3 is 2. 2 squared is 4. 4 minus 6 is negative 2, okay? Again, you'll notice that our graphs should be symmetrical, right? So when we do this, you don't even have to do twice the calculations. You could assume that this point will correspond with this outside point here, and that this point will correspond with this outside point right here. Y'all see that? You see how they repeat? Y'all see that? So you could save time by not having to do all those calculations. Next thing we're going to do is plot our points here. And we're going to finish by graphing it, okay? I'm going to pick a couple more points. I'm going to pick 0 and 6 just to get some more points up on the graph, and I solve for those. Okay, and I draw my graph, draw some arrows at the end, and we're done. I know that this is a major Y parabola because it opens up, okay? So you should know that. When it opens up or down, it's major Y, okay? So this looks like a hyperbola, but is it a hyperbola? No, it's just a section, or well, it's similar, but it's just one part of the hyperbola if we were to look at it that way. Okay, so that's number one. Watch me do number two again, one more time. Number two, first thing you want to do, make sure it's in vertex form. It already is. If it's not, we'll learn how to complete the square, put it there. Figuring out my h and k, x minus h, so my h is 2, and my k is -1. So I'm going to put that as my vertex. Next thing I do is figure out a. A is -2, so since a is -2, it's a negative number, we know it's going to open down. So I could plot my center, my vertex, and I know that it's going to be opening down like so. Okay. Next thing I'm going to do is make an XY table. I know that our graph should be symmetrical, so our vertex should be in the middle. We said 2, -1 is our vertex. So I'm going to pick a couple of smaller points then too, which is 1 and 0. A couple of bigger points are 3, 4, and I'll even put 5 and -1 there. Okay. Putting -1 in here. -1 minus 2 is -3. -3 squared is 9. 9 times -2 is -18. -18 minus 1 is -19. Okay, so put -19 here. I know it's symmetrical, so I could put -19 all the way down here. Unfortunately, our graph paper that we have here doesn't go down to -19, so we don't have to worry about that. Next is 0. 0 minus 2 is -2. -2 squared is 4. 4 times -2 is -8. -8 minus 1 is -9. So I can put -9 here, and I'm also going to put -9 down here. Okay, next one is 1. 1 minus 2 is -1. -1 squared is 1. 1 times -2 is -2. -2 minus 1 is -3. And I'm copying that right down here too, right? Because all of these should be reflected on this side of the graph too. These are all coordinates now, so I'm going to plot my points. And I'll estimate for that -9 and draw my graph with arrows at the end. I know it's a major Y graph, so, or major Y parabola. And we're all done. Okay? Does that make sense?
Yeah.
Questions? Raise your hand if you remember this. It's kind of familiar to you. Okay, good. We haven't done the vertex form yet, which is the way we want to look at these graphs. Make it really easy, but this should be very similar to what we've learned. Okay, and I've taught you this before at the beginning of the year, or near the beginning of the year. All right, so I'd like you to do today's Thursday, so let's have the 2s tell the 1s about number 1. How did I graph? How did I, tell them the whole process. Once they're done, then 1s will tell the 2s about number 2. And then write these down. Okay, ready, set, go. Okay, so y is equal to x plus 1 squared plus 4. Okay, it's already in vertex form, which is real nice. If it wasn't in vertex form, we'd complete the square, but we're not going to do that today. So, all right. So what's my vertex? -1, 4. Correct. Okay, so we could plot that. And what's my a? 1. So is it going to open up or down? Opens up. Okay. So now we know that our parabolas are symmetric, so we could make an XY table with -1, 4 in the middle. Okay. What are 2 smaller points than -1? Good. -2, -3. What are 2 bigger points than -1?
0, 1.
Okay, good. Now when I work this out, which point do I want to start with? Do I want to start at the top of -3, or what do you think would be easier?
0.
0. Good. Does it matter where you start?
No.
Why not?
It's the same on both sides.
It's the same or symmetric on both sides. We could assume if we calculate it correctly, you could assume it's going to be correct. Okay, so let's work with 0. 0 plus 1 is? 1 squared is? Plus 4 is? 5. Okay, so we're going to put a 5 here. And where else can I put a 5? Good. Okay. Next, 1. 1 plus 1 is 2. 2 squared is 4. 4 plus 4 is 8. Okay, and of course we're going to copy it there. Makes sense so far? Okay, now we're going to graph this. -1, 4 is our vertex, so graphing all the points around, and that's it. We knew it opened up, so we did it correctly. Cupcakes. right? Questions on number 3. Okay, I'll give you a moment to copy that. Continuing, let's do the next one, number 5. I'm going to jump to 5 because number 4 was just like 3. And if we could, it's cupcakes, right? Number 5, what's missing here?
The Y. The Y.
The K, right? So what's my vertex? Focus, kids. What's my vertex? No. No, not -3. 3, 0. Okay? So when there's no K, we could just put a place marker for it. Just put a 0 there. It doesn't matter that we put a 0 there. It doesn't change anything. It's just a place marker. Okay? So 3, 0. Okay? A is -2. So it opens up or down? Down. Okay. So what do we know about our quadratic or parabolas? They are what? They're like our face because they are symmetrical. Good. Okay, so we're going to put 3, 0 in the middle. What are 2 smaller points and 2 bigger points? And 3.
2 and 1.
2 and 1 and?
4 and 5.
Okay, good. Let's put 1 in. Tell me what happens when I put 1 in. Work that out. Okay, and then what happens when I put in 2? Good, -2. Good. So we're plotting our points, and that's our graph. We're done. Okay? Questions on number 5. Did you see how fast we did that? So these are going to be a little more, done a little bit more quickly than the other ones. Okay, next one, number 6. Now, number 6, what do you notice is missing?
It's not in standard. Oh, man.
Technically,
The parentheses. Parentheses.
okay, are you all, so turn to your neighbor, discuss how would you, I heard some correct answers, discuss how would you figure out what your H and K are here?
Complete the square. Would you factor out negative? Complete the square.
Okay, so, what's my H and K?
4 and 2.
Wrong.
4? Come on, bro.
I just guessed.
0 and
Is there an H up there?
no.
What do we do when we don't have an H or a K up there? We put in a
0.
0, right? Good, because those are place markers. This is just like saying, look up here, -1/4 times x squared is just like saying -1/4, open parentheses, x minus 0 squared, right? Would you all agree? Did I change anything when I did that? No, we didn't change anything. +2, so what's my H and K, what's my vertex? 2, 0, 2. Okay, so since that's the middle, I want you to finish up the problem. Give me the points that are on the outside. These are going to be a little bit harder. And let me just explain it. What are 2 smaller points than 0? What are 2 smaller points? And what are 2 bigger points? Okay, good. So where would I start on the... Where would I want to start working? From my negative numbers or positive numbers?
Positive.
Positive. Okay, this is how much harder this is going to be. Look at this carefully before you start calculating. Okay? Let's put 1 in. I'll eyes up here really quick. 1 squared is 1. 1 times -1/4 is -1/4, right?
Yeah.
-1/4 plus 2 is
1 and 3.
1 3/4. Okay, so you have to work out some fractions on this one. Oh, so I'm going to go back a smidget. Okay, work out the rest now. Four times -1/4 is -1 plus 2 is 1. There you go.
Yeah, it's 1, but
Okay, now I want some more points because look at, it's just like a few here. So I'm going to put in 3 and the
Oh, it's up in
if I put 3, right? Watch what happens when I put in 3. 3 squared is 9. 9 times, or yeah, 3 squared is 9. 9 times -1/4 is -9/4. -9/4 is like -2 1/4. -2 1/4 plus 2 is -1/4. Okay. So you're gonna have to deal with some fractions. You plot it and you graph it. But why do you think it's wider? Why do you think this one's wider?
Because of fractions.
Because of that A, right? A tells us if it opens up or down, and also tells us how fat or skinny our quadratic is going to be. The bigger A gets in the number wise, the skinnier your quadratic equation is going to be, or the graph. When A becomes a fraction, it gets fatter and wider, okay? Does that make sense?
Yeah.
Yeah.
Good. Okay. That concludes this lesson.